Hello, today we're going to talk about regular polygons and how to find their area. So let's start off with the area formula. The area of a regular polygon equals 1/2 of the perimeter times the apothem, and this would be on your formula chart. Let me go ahead and reiterate. The P stands for the perimeter, and the A stands for the apothem. Now, the perimeter, you might be familiar with, you should be by now. It's just the distance around the outside of an object. But the apothem, that is probably a new vocabulary word. So let's break down all the parts of our regular polygons and see if we can identify what the apothem is. We're going to start with this long edge here. And this is, of course, just the side of my polygon, which in this case is a regular triangle or equilateral triangle. Okay, equilateral triangle. And this dot that's in the center, we just call that the center. Okay, that's the center of my equilateral triangle. Now, from the center, we have a couple of lines going from it. This bold line, we call that the radius, because if we drew a circle around our triangle, the edge of the circle would meet at this corner, and this would be the radius of that circle. So we just call that a radius. It's the same thing, except for it happens to be the radius of the triangle. And this dashed line, this is the line that we actually care about. This line is our apothem. And this is the one that we have to find. So we need to know the side so we can find the perimeter, and this dashed line so that we can find our apothem. Let's go ahead and identify these pieces on our other shapes. So here I have a regular quadrilateral, otherwise known as a square. This top portion that's marked out, that's our side. The center is still our center. This bold line that goes to a corner, that is our radius. And the line that goes from the center straight down is the apothem. One thing that's important to note is that our apothem always cuts this side in half. It did the same thing on our triangle. It cuts our side in half. Now let's look at one more shape. That's our regular hexagon. Not a special name for this one, just a regular hexagon. This would be our side, and remember that all the sides are the same because it's regular. The center point is our center. The line that goes from the center to the corner is our radius. And the line that goes from the center to the side is our apothem. Now, knowing what these are doesn't help us much to find the area unless we can figure out how all of these things are related. So let's go ahead and look back at our triangle. And let's go ahead and put some numbers over here. Let's say that I say that this side is 12 units. Well, with it being 12 units, I know that this piece would be 6 units. And now, using that, I need to be able to figure out what my radius and apothem are. Well, let's think, if I have an equilateral triangle, that means that all of my angles are 60 degrees. So this one is 60, this one is 60, and the whole thing over here is 60. And my radius, because of the nature of a regular polygon, is going to cut that in half. And so this is just 30 degrees. Now, given that this is a 30, 60, 90 triangle, there are some rules. The short leg is x units. The long leg would be x on the square root of 3 units. And the hypotenuse would be 2x units. And those are just properties of 30, 60, 90 triangles. And so if I'm given one side, I should be able to determine the others. And so since this is 6, that means that it is the x on the square root of 3. That's the long side. And I need to divide by the square root of 3 in order to get my apothem. So if I do 6 divided by the square root of 3, that's going to give me 2 on the square root of 3. And so 2 on the square root of 3 would be my apothem. Finding the radius, I would just double that, but I don't actually need the radius because all I need is the perimeter and the apothem in order to match my formula. So, what would my perimeter be? Well, if one side is 12, that means that the whole thing is 36. So my perimeter would be 36 units. And to plug this in, I would do that my area equals 1/2 of the perimeter times the apothem, which gives me 36 square root of 3 as my area. Let's see how that works for squares. And so on my square, let's say this time they gave me the radius, and they said that this radius was 4 units. Now, knowing that the radius is 4 units, that doesn't tell me directly about either the apothem or the perimeter. So let's see what kind of triangle we have here. Sorry, what kind of angle we have here on our square so that we know what kind of triangle we have in here. Well, normally this is 90 degrees, and if our radius cuts that angle in half, then that means that this is 45 degrees. And I now have a 45, 45, 90 triangle. Now on these, my legs, if they're length x, then my hypotenuse is length x root 2. So to get from 4 to here, I know that the 4 is x on the square root of 2. So to figure out what x is, I need to divide by root 2. So 4 divided by the square root of 2 is 2 on the square root of 2. And so this would be my apothem, 2 square root of 2. And if this is 2 square root of 2, that means that this is also 2 square root of 2. And because this is half, that means that the whole side would be 4 on the square root of 2. Now I also need to know my perimeter. And to find my perimeter, I just take one side and I have 4 that are the same, so I do that times 4, and that gives me a perimeter of 16 on the square root of 2. And now I can apply the formula that the area equals 1/2 of the perimeter times the apothem, and let's see what this gives me. Well, 16 times 2 is 8. Half of 8 is 4. So I have 4. Square root of 2 times the square root of 2 gives me 2. And 4 times 2 is 8. And so my area would equal 8 units. All right, one more shape. That is our regular hexagon. And if you've noticed, I've picked these shapes out because these triangles become our special right triangles that give us some shortcuts to finding their sides. Well, let's say we've already worked with them giving the side and giving us the radius. Let's say this time they tell us that the perimeter is 24. So our perimeter is 24. To find our side length, I have 1, 2, 3, 4, 5, 6 sides. 24 divided by 6 gives me a side length of 4. Taking that side length to figure out what half of that is, that would just be 2. And let's look at the type of triangle this is. Well, it wouldn't be too hard for me to look up and rediscover that the degree of this angle is 120 degrees. And if I cut that in half, that makes this a 60-degree angle. And again, I have a 30, 60, 90 triangle, like I did with my triangle up here, but this time it is turned so the 60-degree angle is down here. So if I draw my 30, 60, 90 triangle, this time this is the x, this is the x on the square root of 3, and this is the 2x. Now, I already know my perimeter. We're just looking for this apothem piece. If this is x, that means x is 2. And this is x on the square root of 3. That just means that this is 2 on the square root of 3, and so that is my apothem. Now, my apothem being very easy to find here, I can go ahead and do 1/2 of the perimeter times the apothem, and this gives me 24 on the square root of 3. And so that is how we use the apothem and perimeter to find the area of regular polygons, specifically for triangles, quadrilaterals, and hexagons that are regular. If you have another shape, then you would need to figure out what this angle is, so you should cut it in half and use trig ratios. But these three basic ones you'll probably see most often. Thank you and have a good day.